to end this lesson on parent functions and transformations, I wanted to introduce to you 5 basic parent functions and some of their basic transformations visually. Now, we will be working with each of these and many more algebraic functions throughout the course of the year, so you don't need to learn all the nitpicky details to each of these at this point. However, I do want you to recognize some of the generalizations that take place. And so as you're looking at these, and there's 5, and I've only got 4 on the screen right now, but there's 5 of them for you to be familiar with. Notice that the original function, or what we call the parent function, is the red graph, and then the yellow and the green graphs are some sort of transformation that's taken place for the parent function. Now, we've introduced to you the idea of an h and a k. The h is making the function move horizontally, left or right, and opposite of whatever its sign is. The k value is affecting the transformation vertically, so it's vertically sliding it up or down. And then the a value will reflect it if it's negative, and then depending on whether it's greater than 1 or less than 1, it'll shrink it or compress it. So that is a good general start. You've learned all these on generic looking graphs, and now we can see how they work on algebraic functions. And so take a quick visual scan of what's given to us here. These are very important bits of information. You will be tested on these 5 functions on your unit test. A couple points that I'd like to make while we've got it all here. Linear function, obviously, all going straight. A quadratic is U-shaped. So when you're trying to graph this, make your best effort to make a U out of it, more or less. Whereas the absolute value is V-shaped. Generally speaking, students will try to connect the dots on a quadratic, and then inevitably their graph ends up looking like an absolute value. So just be very aware of that. A cubic has kind of this curvature looking shape, and then square roots are actually sideways quadratics, but we only have half of the quadratic, and we will discuss why in more detail when we get to square root functions. But for right now, if you understand those basic things, you should be good. Lastly, with these 5 functions, notice that the parent function goes through the origin 0, 0. Now, this will not always be the case as we get to more advanced functions in Algebra 2. However, for right now, you can think of 0, 0 as a great starting place for your parent functions. Okay, so let's take a look. I've given you sample problem number 4, and what I've asked you to do on sample problem number 4 is to graph each of these functions. Now, they're all quadratic, so they all ought to have some sort of U-shaped looking situation there. What I would like you to do is to T-chart a few points, and then after you graph the points and draw the quadratic, check it on your calculator. Now, generally speaking, if you remember the old T-chart, -1, 0, and 1 are great places to start as far as picking x values is concerned. Remember, you have the option to pick any x value that you want and find what the corresponding y value is. Now, I can tell you as these graphs translate or reflect or scale, that different x values are going to be needed. So -1, 0, and 1 will not always give you the complete picture or the best picture, so keep that in mind as well. So go ahead and stop the video, do the best you can to graph these 4 functions, and come back and take a look at the solutions. Okay, what I've done is I've gone ahead and graphed each of these and filled in the T-charts, and I've spared you having to watch me do the order of operations and fill in each of these T-charts and graph it. However, I do want to point out a few things of each graph. So Notice I use -1, 0, and 1 as a starting place for each of my t-charts. And in the first two parts, Part A and Part B, they gave me a clear enough picture to graph those points and then go ahead and draw the picture. Actually, if you look closely, I've also done 2 and -2, which gave me 4s here. I've also done 2 and -2, which has given me 7 on both of those, and so it gives me a little bit better view of my U-shaped quadratic. Notice here that this shifted the graph up 3, which is right in line with what that K value should do. It should vertically translate that up 3 units. Now, if we move down here to C and D, notice that if I graphed just -1, 0, and 1, especially on Part C, it really didn't give me a clear picture. Matter of fact, I could have made the mistake of it looking like a straight line. And so that's why it's very important to understand what your final answer should look like. Knowing that it's a quadratic, it shouldn't be a straight line, so we're going to need additional points. And that's where I came in with 2, 3, and 4 and got a better picture. Now if you notice on this one, it actually shifted it 2 to the right, which is what it should do because we're working the opposite. So it's an H value, and we're always doing the opposite of the H value. So instead of to the left, we do to the right there. Now in Part D, we wanted to see if you could kind of put all this together. We have a -A value, so that's a -1. That's going to tell us that it's going to reflect. Then we also have an H and a K value, and so you can see we're coming over 1, down 2, and then we've also reflected the graph to get the resulting transformation. So work on that. Also check those in your calculator. That'll give you great practice graphing these in your calculator. If you have any questions about how to do that, be sure to ask in class.